When you have a sequence, you can actually find what's called the series. And the series is the sum of the terms of a sequence. And this can either be finite or infinite, and I'll explain what I mean by that shortly. So let's first talk about a finite sequence. I think I'm going to get a fresh sheet of paper here. So let's talk about a finite sequence, and a finite sequence is a sequence that ends. So 3, 6, 9, 12, 15. That would be a finite sequence. An infinite sequence would be 3, 6, 9, 12, 15, ... because it keeps going. So we'll start here talking about finite sequence. And whenever we're talking about arithmetic sequences like these, notice that it's +3 every time. I can find the finite sequence. Like I could find the sum of the first 100 numbers in this sequence. I can find an exact number. But if I try to find the sum of the infinite, that's impossible because I would just keep adding a bigger number all the time. So let's talk about finding the sum of this finite sequence. And I'm going to just use something easy here. We're going to find the sum of the first 5 terms because we already know what that is, so we can check our work. So the first thing I have to do is write the rule. And the rule for this one is it's increasing by 3. So it has a slope of 3. And you could go, if you wanted to, and use the n minus 1 times d. But then I'm going to go backward then and think, okay, then the 0th term, if I minus 3, would be 0. So the rule in this case is 3n. The formula to find the sum, and I'm going to give you this formula on the test, to find the sum of an arithmetic sequence is n times a sub 1 plus a sub n over 2. And each of these things represents something. N represents the term number. A sub 1 is the first term, and a sub n is the rule. So let's find the sum of the first 5 terms on this one. So I'm going to find the sum of the first 5 terms. So in this particular case, the n is going to be 5 because I'm finding the sum of the first 5 terms. The first term of this sequence is 3, and the rule is 3n over 2. And then in place of the n, since I'm finding the first 5 terms, I'm going to put a 5 where this n is. So I've got 3 plus 15, which is 18, divided by 2, times 5. And 18 divided by 2 is 9, and 9 times 5 is 45. Let's see if that's true. 3 plus 6 is 9, 9 plus 9 is 18, 18 plus 12 is 30, plus 15 is 45. So you can see how this rule gives us the sum of the first 5 terms. We could find this for anything. Let's say I wanted to find the sum of the first 50 terms of this sequence. Then I would do sum of first 50 terms, and I would put 50, and then the first term, which is 3, plus the rule, which is 3n, and we would put a 50 here, divided by 2. So 3 times 50 is 150, plus 3 is 153, divided by 2, times 50. And if I multiplied that out, I would get 3,825. So if I kept writing these out until I got to 50 numbers, so just kept writing this out until I got to 50 numbers and I added them all together, the sum would be 3,825. Now, this is one method of finding the sum. There's another method that you can use on your calculator, and it's called summation notation. So summation notation looks like this. Got this symbol, and here we have a number, and here we would have a number, and here we would have a number. So we would have something in each of these spots. This spot represents the lower limit. This spot represents the upper limit. And this spot is for the rule. So let's go back and let's use the rule that we had, a sub n, which is 3n, and let's use summation notation to find the sum. So we wanted to find the sum of the first 5 terms. So when I put this in my calculator, I'm going to have the sum from term 1 to term 5, and I could use an n here, but since the calculator is already in a mode of using x for the input value, that's what we're going to use. So I'm going to go from term 1 to term 5 of this particular rule, and so I'm going to change this to an x because we made this a x. So let me show you how to find it on your calculator. So I'm going to push math, and then I want to go over, let me make sure it's on the screen. I'm going to go down to 0, see where it says summation notation, and then it brings up something that looks like this. So in this particular spot then, I want to put an x and a 1, because I'm adding the first term and then arrow up to the 5th term. And then in the box here, I'm going to put the rule, which was 3x, and hit enter. And what it did is it calculated the sum of the first 5 terms for me. There were 45. Let's do the one we did, what did we say, the first 50 terms? So I'm going to hit second enter so I can just pull that same thing up. If I wanted to find the sum of the first 50 terms, I would put 1 to 50, and that was 3,825, the same thing that we got when we did the formula ourselves. So let's do another one of these, and we're going to use our calculator.